All right, let's take care of Chapter 9, Lesson 1. I'm going to leave my screen in non presentation mode because I have to skip around in tabs and it'll just be a lot easier for me. So, this is going to be all about the different states of matter. You've often heard of this as just solid, liquid, gas. So, a couple of words we need to make ourselves familiar with. The book is going to use the word fixed, and the book is going to use the word definite or indefinite. Fixed means not changing or not moving, and definite means not changing. Um, so if we look at this lucky horseshoe that's been nailed to the wall, we can say that it is fixed to the wall. It's not like it was broken and needs repaired. It just means that it's been made so that it cannot move. So fixed means not moving around. Um, all right. So in a solid, the molecules are in a fixed position, and that means that the molecules or atoms are in place and they're not really moving very much as far as one place to the other. They are still moving because they are vibrating in place. And if we look down here at this diagram, we can see these little motion lines showing that they're not moving, but they not moving around, but they are vibrating in place. Um, so the particles are packed very closely together and they are in fixed positions. They still have some energy, and so they are vibrating in place. No matter ever really sits perfectly still. So in a solid, the atoms or molecules are in a close and fixed or unchanging position. They have that means that as a shape or as a substance, they have a definite and unchanging shape and a definite volume. Solids keep their shape in a container. So if I have a graduated cylinder and I drop in a solid like a rock or a toy car or something like that, the solid is going to keep its shape. It's not going to assume the shape of its container. So solids, they vibrate in fixed positions. And here's where I have to jump around in tabs. So let's look at a digital model of the particles in a solid. All right. So here we have the particles. And when I click play, you can see that they're moving as in the respect that they are just vibrating in place. If I hit trace a random atom, um, maybe. What if I mark two atoms? There we go. Okay, so these atoms, they aren't really moving other than just vibrating in place. It doesn't change or swap positions with any other nearby atom. All the atoms are just in place. They're very organized and they're just kind of vibrating in place. So let me hit pause. All right. Liquids have atoms or molecules that are close together, they're touching, but they are in unfixed or changing positions. This gives liquids a definite volume, it's an unchanging volume, but an indefinite shape. So liquids have a definite volume, but indefinite shape. They don't keep their shape in a container, but they do keep their volume. And when we've been pouring liquids into graduated cylinders, the total volume doesn't change, but as I um, tilt and turn the graduated cylinder, the liquid will move around. And if I pour the liquid in one graduated cylinder to another, the volume stays the same, but the shape of the liquid remains the same. So liquids have more movement, but the atoms or particles or molecules are still connected. So let's look at that digital model. So right away, without even hitting play, we can see that the structure is much less organized compared to a liquid. And when I click play, you'll see that there's a lot more movement. Um, these move faster and more than a solid, and that's because they're generally at a higher temperature for its substance. So when I click mark two atoms, you'll notice that this atom it does move around and it will swap places with nearby atoms. So these particles are definitely not in fixed positions. They can move around and change positions with other nearby atoms. So let me reset and hit trace. Let's see if I can get that to work. Yeah, there we go. We can see it's got like this purple line here. We can see that there's a little bit more movement. They are definitely not in fixed positions. All right. Gases have atoms or molecules that are spread out. They are not touching. So in solids and liquids, the particles are still next to each other and kind of touching. But in gases, they are spread apart. They are disconnected from each other. And that gives them unfixed positions. And they also, because they're not touching, have an indefinite shape. They don't keep their shape in a container and they do not keep their volume. They always assume the volume of their container. Um, if you could pour gas from one cylinder to another, it actually can be done and under the right circumstances. They would take the shape of their new container. So liquids have the whoops, this should be gases. Gases have the most movement compared to solids, liquids, and gases, and they are not connected. So when we look at this digital model, right away we can see that some are still kind of connected, others are not connected, and then these connected points will break from time to time. So when I click play, whole lot more movement. Connections are being broken and reconnected. They're bouncing around this, banging into each other and the sides of their container. If I mark two atoms, definitely we can see that they can swap places with other particles. And we have the most movement and an unfixed shape. So pause. Okay. So solids have a definite shape and volume, and as you can see, when put into a container, they keep their own shape. Solids, that was solid. Sorry, liquids have a definite volume but an indefinite shape, so they will always kind of take the shape of their container. Gases have no definite volume and no definite shape, and so whatever container they're in, they will just spread out and take up the entire container. All right. Gas pressure you will be introduced to into this in this section. This is pressure is caused when gas particles collide with each other and the walls of their container. When I go back to here and I click play, you can see the particles are banging into each other and they're banging into the four sides of our container. Every collision will create something called pressure. The more collisions there are, the more pressure there is. And we're going to talk in lesson 3 in this chapter about more ways to get collisions. But for now, what you need to know is that concentration, how close they are together, and the amount of particles is going to increase or decrease pressure. So when we look at this diagram, these would be moving and they would be banging into each other, but they're in a much bigger space. Here, if you count the reds here and you count the reds here, there's the same amount of atoms, but because this lid has been pushed down, they have much less room to spread out. And so they will hit each other more and they will hit the sides of their container more. And that's going to give us more collisions, which will increase pressure. So this is low pressure because a low amount of collisions, and this is high pressure because there will be more collisions. That's it. So you're going to read chapter 9, lesson 1, answer all the questions. Now, in the book, please pay special attention to how pressure is calculated. There will be quiz questions on this. Then outside of this, on the weekly guide is a activity, and it's going to be about the different types of solids, and there will be quiz questions on that. So there's kind of 2 heads up on things you're really going to want to pay attention to this week. That's it, and have a good week.